The Afterglow algorithm is designed to specifically detect red clouds at sunrise and sunset. In order for photographing those red clouds, you need to have a high cloud cover which stretches from your position, from your photo spot to the horizon. But then it's really important that there is a little gap between the cloud cover over your head and the horizon. So in order for the clouds over your head to get this nice red color at sunrise or sunset, you need a prominent cloud edge where the cloud cover just stops to let in the light from the rising or the setting sun at the horizon. Then the light from the sun at horizon can travel beneath the clouds over your photo location and can light them up in this nice red color. And this is what our algorithm is specifically designed for, to detect this specific constellation in the clouds. If you look at this satellite image, you can see the perfect situation for red clouds at the sunrise. You have this prominent cloud edge where you have no clouds on the eastern side where the sun is rising, and you have a fully covered sky on the western side of this cloud edge. And now when the sun is rising, the light from the sun can go beneath those clouds, can travel down under those clouds at the specific cloud edge. And what our algorithm now does is it calculates the position of the sun respective to the time of the year, and afterward it marks which area of the clouds can light up red. So now we have a small problem. We cannot exactly tell if it's a big area or a small area or an even bigger area of the clouds which will light up, because sometimes only a small area around the edge will get red clouds, and sometimes it is possible that over hundreds of kilometers you can see the red clouds and the whole sky is just burning. But it is not possible for us to calculate this situation. We can only calculate an area where we are pretty certain that the clouds will turn red. Here you can find a typically situation at sunrise with really much red sky predicted for all over Germany. And now what you can see is there's a tool sticking to the center of the screen. This tool is called the placement tool. And as you can see, it has different probabilities written to it. You can see the center one, the green one, it says ideal. Then comes another one, it says high probability. Then we get medium probability, and the most other one says low probability. And this tool is now used to place yourself in a right position relative to the red sky predicted on the map. The reason for this tool is that we can, as explained, not exactly tell over which distance it will be possible to see the red clouds. So if you want to be really certain that the sky will light up in red, you should always stay within the ideal range. The camera marks the perfect position you will find relative to the red sky predicted on the map. And if you stay in this specific distance, you will find the perfect distance to get red clouds over your photo spot. If you would stay further away from the red area marked on the map, then the probability will go down that you can actually see the red clouds. The more distance you have, the lesser probability to see the red clouds. But sometimes it will be possible to see the red clouds over such a great distance of several hundred kilometers. But the most highest probability is if you stay close to the red edge. And the place where you should go is always marked by this little camera in the center of the screen. So if you want to find out which areas to go, use this as a template to just put over the red sky, see where the small camera is, and then you can go in this specific area. Like in France, it would be like this area here you could go, and so you can just check out all the areas which would be possible for you. So if you would be around here in the UK, there is no red sky forecasted right now, so no red clouds possible, and the best chance would be here in the center of Germany. When it comes to clouds, only one specific type of cloud is beneficial for red clouds at sunrise or sunset. Those are the so-called stratus clouds. Stratus are clouds which can stretch over hundreds and hundreds of kilometers. So they make up for really big cloud areas and are mostly in front of big weather systems. So we take this specific type of cloud to be beneficial for the red sky at sunrise or sunset. Then there are the cumulus clouds. Those are clouds with a mainly vertical stretch. There's a small type which is just called cumulus, and also there are the really big cumulonimbus clouds which form in thunderstorms. Those two types of clouds, the cumulus clouds, are non-beneficial to red skies at sunrise or sunsets most of the time. There's some specific light situation where you can get a really nice sky within a thunderstorm at sunrise or sunset. Okay, but most of the time they are non-beneficial and they just block the sunlight. And so we calculate them into our algorithm as negative cloud types. Next important thing about clouds is their height above the sea level. So it is split into three parts. You got the low clouds, which stretch up to 2,000 meters. You got the mid-level clouds, which go from 2,000 to 7,000 meters. And then you have the high clouds going from 7,000 meters and above. When it now comes to afterglow at sunrise or sunset, only the mid-level and the high clouds are beneficial to have this largely red skies at sunrise and sunsets. When it comes to the low clouds, they are problematic for sunrise or sunset to see the mid-level and the high clouds, which means that the low clouds, which can be like fog or dense cumulus clouds, they mostly just block the view onto the actual red clouds in the mid-level or in the high clouds. So there's a second parameter we added into forecasting the red sky at sunrise or sunset, and this is the afterglow visibility parameter. Here in this example, you can see what is so problematic about the low clouds when it comes to see a red sky at sunrise or sunset. Most of the time, the low clouds will just block the view. In this case, we have a really big range of low clouds in the mountains. And when you're under those low clouds, you would never have a chance to see the red clouds above them. So therefore, we have the afterglow visibility parameter, which calculates the area of the low clouds, and from which point you can actually see the red sky. So even if you have a high chance for red clouds in your area, but then the visibility is low, then the chances that you can actually see the red clouds are pretty low. That's why you have always to consider both parameters. So what you now have to do is, after you found your photo position with the placement tool relative to the red sky forecasted on the map, you need to click in the down right corner to switch to the visibility. Now the map has changed and you see a new weather parameter. You are now seeing the afterglow visibility parameter. At first, when you look at the top end of the map, you can see the scale. When something on the map is totally gray, this means that this is a place with no visibility chances to see the red sky. Only the areas where the map has a high visibility are the areas where it is actually possible for you to see the red clouds. Now, if I zoom in, there are some areas which are specifically marked yellow as fog. Because if you think about it, is possible in mountain ranges to be above the fog, and therefore we specifically mark the fog as yellow on the map for you to have a chance to be on a mountaintop to see the red clouds from there. And so now you have to check for the area where you can actually see the red sky. And for convenience, you can just switch in the down right corner with the button between those two parameters, and you can find your ideal position with that. So in this case, we would see that a good position for photographing the red sky would somewhere here be in central of Germany, like this area here. If I switch now, I can see from this specific area here, it would be possible to see the red clouds, and I would have an ideal position. When I go to northern Germany, after problem, I would be perfectly in position for the red sky. But if I check the visibility, I would see that I'm pretty close to an area with zero visibility for the red sky. So this would be not an ideal area to see the red clouds. So here's another example. You can see that the positioning tool has changed its direction because we are now looking at a sunset. So the light of the sun is coming in from the west. And you can see there's a pretty nice area of red in the center of the United States. If I want to have the ideal position, I would need to stay a little bit east of the red markings. So you can see this is the perfect area to go there. And now afterwards, I have to check if it would be possible to see the red clouds from this position, or if there would be some other low clouds which could block the view to the red clouds. So I switch the parameters. Then I can see there's only one small area in the northeast of Kansas or southwest of Iowa, which is blocking the view. So most other parts are really good in sky visibility for the red sky. So if I look again, a good area to see the red sky would be the northwestern part of Iowa or the southern parts of Minnesota. Because in this area, there is a high visibility for red clouds, and there's also a really good placement relative to the marked red clouds on the map. When you want to take a look at the sunrise, you can just go down the corner and choose the next sunrise. Now you can see that there are plenty of chances to photograph a red sky at sunrise. And you can see also that the direction of the placement tool has now changed again to the eastern side. If I want to have a red sky here on the southern side of Michigan, a nice position would be like here, somewhere west of Detroit or Toledo. And now I have to just change to the Afterglow visibility, and I can see that the map stays totally clear, which means that here around is a pretty good chance to see red clouds at sunrise. And the further I would be away from this area, the lower the chances to see it. So I want to be pretty close in this ideal range to the red sky.